Okay, so we're going to carry on with what we were discussing yesterday. We're going to move on to problem number 4. And problem number 4, actually that's 3-phase wide. Let's back up. How about problem number 3? Let's do problem number 3 before we get to problem number 4. How many of you have gotten to Y connections already? Okay. We'll try and, we're not going to rifle through it, but what we're going to do is we're going to try and move it a bit of a, not a fast pace, but maybe a bit more accelerated than what we did yesterday, particularly now that you guys know how to calculate power. Not that you didn't know before, but it's going to be very much the same here when we get to power and Cartesian plane with a couple minor differences. So, problem number 3, we're looking at a parallel resistive inductive circuit. And you can see that on the screen here. And so I have some things figured out. First of all, yesterday I know it seemed a little cumbersome. I was kind of all over the place, but I think I have some things figured out today with the new screen, which should help. So very first thing we want to do here is it says find individual branch currents, impedance of the motor, line current, power motor, power circuit, power, some sort of power, reactive power, you get the idea. So we want to start by, first of all, calculating the individual currents in each phase. So we actually want to go in and look at current here and current here. We want to determine what our currents are. So how would we do that? What's step 1 here? What do we need to know? Do we have enough information right here in branch number 1? Solve for current. What about over here? What do we have to, before we can solve for current, though, what do we need to know here? We need to know impedance, right? We need to know Z motor before we can do anything. Make sure this is it keeps reverting back. So what we're going to do then is we're going to start by extending the page here. We're going to complete a triangle, an impedance triangle of the coil. So we're going to go Z coil. All right. Now, Z coil, we already know XL, so that's already been calculated. We know R motor as well. So you could, at this point, you can do a triangle if you want. You guys are 4th grade, you've done probably 100 triangles by now over the last few years. Or you could just say Z coil is going to be the square root of what? R squared plus XL squared. We could just use Pythagorean theorem, right? If you want to develop a triangle, you could also do that. Simply come up with your triangle. We're going to solve for Z over here. We already know R and we already know XL. Okay? I think at this point it's probably just as easy to put in some numbers. So if we do the square root of our resistance, which is 30 ohms squared plus 66 ohms squared, Z should come out to, let's see here, Z should be 72.49. So most of you guys are probably following along. Let me know if that's also what you got. Yeah? Okay. So now that we have that, now we can actually solve for some of our individual currents. So unlike our series circuit where we knew current was common through all the loads and we had to solve for the individual voltages, now what we're doing is we have one voltage, neglecting line drop. You guys get that part, right? We're not going to look at any line drop here at this point. It's strictly theoretical. So we're only looking at the loads themselves, no line drop at this point. But given that, we have to look at the individual currents. So we could start by looking at calculating the current of the resistor. Now, what's the formula for that? Go ahead. Somebody say something? IR. Okay. So, aren't we going to just take what? Voltage of the resistor? What are we going to divide that by? It's just Ohm's law, isn't it? Just the resistor? Yeah. Voltage of the resistor in this case, 240 volts. And we divide that by 33 ohms. And if we've done that correctly, we should come out to 7.273 amps. Now, good thing to do here, go back up here and let's put that in. So we have 7.273 amps at that point right there. Okay? Now the next one, we've calculated presented the motor, so now we want to solve for the current in the coil. So again, I'm going to extend the page. And the formula is very much the same. Now we're going to look at the current through the coil. We're going to look at the voltage coil, and we're going to divide that by what? Are we going to divide it by R coil? No. Z coil, good. So 240 volts, and we divided that by 72.49. And that should give us 3.31 amps. Now, I'm going to stop right there, and I want you guys to consider something. In the case of the resistor, what was the relationship between the current and the voltage in the resistive branch? It was in phase, good, right? Are we in phase here? So that means we're out of phase, right? How do we know how much out of phase we are? By the power factor, good. So what I like to do is, if I was to just backtrack just a tad here, over here, this current of 7.23 amps, we could go like this and put angle 0. Angle 0 just means, or 0 degrees, it simply means the current's in phase with the voltage. That's not necessarily, when we get, particularly when we get to 3-phase, that's not necessarily where it's going to be at on the Cartesian plane. However, it just indicates that we are in phase. When we look at the current of the coil, as you guys just pointed out, we're going to have an angle here. Now, in order to do that, there's a couple ways of doing it. We can look at what is the power factor. Well, the power factor is simply our in phase divided by the total. Just have to do a little bit of eraser work here. There we go. And so, if we look at our power factor, we're going to take our motor and divide by, or our coil. I mean, this is a single phase. When we talk about coil motor transformer, it doesn't matter what kind it is. I had our motor here, it could be our coil. Divided by Z motor or Z coil, same thing. So if we take 30 and we divide that by 72.49, you should get 0.414. Now, how do we convert that to an angle? Second function cos, you bet. So if we take that, so theta is equal to cos -1, which just means second function cos or inverse cos. So if we inverse cos that, what do we come up with for an angle? Good, 65.54, is that? 556, I have 54 for some reason. Now, my question is positive or negative? Negative. Why negative? Good. Current lags voltage. That negative tells us that current lags voltage by 65.54 degrees. Correct. And so now when we go to the Cartesian plane here in a little bit, we'll know exactly where these particular currents need to be plotted. Now, given that, this must be my sheet. Yeah, that's what it is. It's my sheet hitting this thing. Or why it was, we had all these little squigglies, that's why. So, now that we have the two currents, is there a way of adding those two together that you guys recall from last year to come up with what our line current will be? You guys remember how to use mode 3? Okay, well, first thing we're going to do is we're going to write them down so we can enter. So we're going to say I line is equal to I of the resistor plus I of the motor or coil, whatever you want to call it. And we know we have to add those two up. That's Kirchhoff's current law. Now, as you guys have already pointed out, there's some angles involved here. So let's take a look at what they are. We already know that I of the resistor is 7.273 amps at an angle of 0 degrees. Now, because this is single phase, that is in fact where it's going to end up on the Cartesian plane, is at 0 degrees. We're going to demonstrate that here shortly. Okay, when we're into three phase, you guys, you can't just go add this because it depends which phase we're looking at. So these angles won't necessarily be at 0 degrees and negative 65, but for single phase it is. And then we're going to add to that 3.31 amps at an angle of, we said negative 65, and you guys said 5.5, right? Yeah. So we'll just go with 5.5, getting a little loose here on my 3 digits, but we'll just go with that for intent here. Now, let's work on this together to make sure you guys remember how to enter it in mode 3. Some of you maybe have already done this in CBAT, but let's do it anyway. So on your calculators, hit the mode button and the number 3. Up in the corner, you'll see it says XY. Up in the display, we don't want it to say XY. Hit second function, number 8. We want it to say R theta. Okay, radius theta. Now what we're going to do is this. We're going to type in 7.273. You're going to hit the DMS button. It's right above the 8 and the 9. That'll put that little angle sign in there. Okay, then you're going to put 3.31 DMS again. Oh, I had to put plus in there. Whoops. I forgot to hit plus. My bad. So after the end, you hit the delete button, you guys, if you're actually following me. Plus 3.31 DMS at negative, don't forget the negative sign, 65.55. And then hit 7.273 DMS 0 plus 3.31 DMS negative 65.55. There we go. You guys get 9.153? Okay, I kind of screwed everybody up there. Did anybody not get it because I was kind of going in circles there? I see you. Did anybody not get it? This is the perfect time to make sure we're all on the same page on this. Don't be afraid to speak up. Okay. So we should have ended up then with 9.153. And when you guys are on the provincial exam, you're going to want to make sure that you can, again, do these calculations the quickest as possible. And this is a good way of doing it. And then if we want to know what angle we're at, hit the second function exponent button. And the exponent button is right above the 7. And that'll tell you that the resultant is negative 19.22, roughly, degrees. So that's where our current ends up, our line current. All right. Okay, now our next move is we have to plot that on the Cartesian plane. So we're going to back up here, go up toward, we're going to use this Cartesian plane here, and we want to plot those currents. So the very first thing we have to do, because it's single phase, is we need to draw what end? What's our common denominator between the branches? Is it voltage or current? It's voltage. So we're going to take and we're going to put an arrow in here to indicate voltage. So this is voltage equals 240 volts, angle 0 degrees. Now in reference to that phasor, now we're going to plot our currents. Now in this case, again, you know how it's always, I always say it's easier to start with the coil or the motor or whatever you want to call it, so let's do that. We're going to start with I motor, and we know that the current is 3.31 at negative 65.54 degrees. Is there another way of representing the angle there? You bet. You could represent it as a positive value for sure, right? So if you were to take 360 and subtract 65.54, you'd end up with about 294.4, well, it'd be 4.5 in our case because you guys are 0.55. So let's draw in a phasor then to represent that. Whoops, wrong one. We want this one. And let's use, in this case, because it's current, we're going to use red. So at about negative 65 degrees, which looks like it's about right somewhere in here, we have 3.31. Let's put an arrow on the end there. This needs to be close. And, well, let's just draw in an arrow here. So this is 3.31 amps at angle negative 65.55 degrees. Now our current due to resistance is a little bit longer, and so once again we'll use red. And we want to make sure that N is this guy. So we're going to put him right, there we go. He's going to be a little longer. About there. And that is I resistor 7.273 amps at 0 degrees. Using the parallelogram method, something like this. Of course, I stuck that right where I shouldn't. I'm going to have to erase that, so let's do this. Put that up top. So this is I resistor equals 7.273 amps, angle 0 degrees. Using the parallelogram method, somewhere over there now we're going to have our resultant, which would be somewhere there. And we said that was 9.151. So I line is equal to 9.151 amps at angle negative 19.22 approximately. And you guys might have 2.3, 2.4. Feel free to write in what you guys got on your calculator. You guys caught that okay? Any problems with that? All right, let's move on to some power. So, motor power or coil power. I've never tried cursive writing on here. I figured I'd give it a try. Power of coil. Do we have enough information to use this one? Yeah, we do. So we could say power of the coil, 240 volts. We're going to times that by a current of 3.31 amps. And times that by a power factor of 0.414. And if we've done that correctly, we should come out to approximately 320, let's call it 329 watts. I'm not going to use decimals there. Okay, you're not going to get that wrong on an exam if you went 328.88 or 329. You're going to get that right. Okay. Now, we want to know Q coil. We can use the cousin of that formula. So same thing. We can use V coil times I coil times what? Sine theta. Good. And if you punch that in correctly, well, first let's go through that. So 240 volts times, in this case, 3.31 amps. And I'm doing this to show that there is some inductive as well. So times the sine, and what I do is, again, I put in brackets 0.414 times cos to the -1. And if you do that all in one step, you'll come out to 723 and change. So we're going to say 723 bars approximately. All right. And then S of the coil. Tell me if I'm going too fast, you guys, for those that are following along. Simply going to take V coil times I coil. Are you guys okay with this here? Okay. You guys okay with that? Want me to backtrack?
Just, it's just the angle then.
Yeah, that's all I've done here is in one step. I'm just getting lazy. In one step, I've just calculated the angle by taking the power factor and inverse cosine. That's all I've done. Just done it in one step instead of doing it separately. And you guys are welcome to do it separately as long as you get the right answer. That's the most important thing. Yeah. 240 volts times 3.31 amps. And that should be 794 V. Lastly, we want to look at circuit power. Man, those welders are loud. I can hear them through the wall for crying out loud. You had a question?
I don't know, I just welder.
Oh, is that right?
Yeah.
Well, you moved up. Good for you.
I don't mind.
I have to be careful what I say because my oldest son teaches welding in Pincher Creek at Mountain Paul, and he just got that job. He got his ed degree, and he's a math teacher, but he's also kind of a trades guy. He's growing up on the farm, so I have to be careful what I say.
Can you go back to that cube?
I sure can. You bet. Now's the time. Where are you? Right here. Q coil, right there. Yeah.
Also, I noticed when you do it, when you punch in your calculator, you gotta do the inverse close before the 0.4.
You're right. You're absolutely correct. You have to go inverse cos and then type in 0.414. Yeah. Good observation. Otherwise, you get an error, right? Is that what you guys was happening? You guys get an error on there? Is it working out okay, Carson?
No, I'm getting like 552,000.
Okay, so here's what you can do. So let me just try to make sure I'm not feeding you a line of bull here. So if we go 240 times 3.31 times brackets, second function cos 0.414 end bracket equals, yeah, you're right, 52. Oh, I forgot the sign, yeah. I forgot the sign, didn't I? Right? Yeah, 240. I'm missing the sign there. So if we go 240 times 3.31 times the sign, brackets, second function cos 0.414 end brackets equals. There you go. Yeah. Yeah, thank you for that. That's a good observation. So yeah, you have to hit sign for again. I'm just trying to do it in one step, but I mean, if it's easier for you to do it to get the angle and then stick it in there, that's cool too. Did anybody else? I'm glad you said something, because if you're not getting that, this is a good time to work it out. Yeah. All right. Is that good, Carson?
Yeah.
Yeah, makes sense. Okay. All right, so let's look at circuit power. So power total, now we can use E line times, it's supposed to be L, I line times power factor. We have, again, that information. You sure could. Very good observation. So here's, can I add my two S's together? No. Okay, so absolutely, if it's easier for you to add your powers together, yes. Can you add your Q's together? Yep. So remember, power is completely in phase, reactive power is completely out of phase. So one's at 0, one's at negative 90. But they're both at negative 90 and they're both at 0. So anything that's exactly the same angle, you can add them up just using the regular math. Yep. Yeah, good observation. You bet. Well, and when you do that, what do you get for an answer here, just out of curiosity? You get 2073? Roughly 2074. Okay, yeah. So if we did this way, we should come out to the same number. It should be 240 volts. Come on now. Times, what did we say, 9.151, and then the power factor we didn't really know, but we do know the angle, right? Negative 19 degrees. So we could just times that by cos of negative 19.22 our room. And if you do that, it comes out to 2074. Okay, something's happening here with my, I don't know if my computer's not keeping up, or I'm just that bad. 2074, and that is watts. Or in this case, how should we be representing that? Kilowatts, right? It should be 2.1 kW. Remember, anything over 1,000 watts as a general rule is represented in kilowatts. Yeah. So Q total, you could use the same formula, or you could simply say, we'll do this one, Q of the resistor plus Q of the coil. Now, or what is something happening here? Is there any Q in the resistor? No. So really, we would say 0 plus whatever we had. What did we have for the Q of the motor? 723. I must have done something wrong in here. I'm just sine of the angle. Because there is no Q in our, so our answer here should be 0 plus basically 723. My notes are out. Which really means we should be at 723. And that should be bars. Now the other way we could have looked at this, and it should work out to be the same thing. Q total should be equal to E line times I line times the sine of the angle. And I was getting 1862. I didn't catch that. Has anybody tried that? No, I just wrote it down wrong. I am getting 723 that way. Yeah, it works out either way, guys, and it should. For some reason, I wrote it down wrong in my notes. At the end of the day, if you do that, we are 240 volts times 9 9.151 times the sine of negative 19.22 degrees. And that comes out to 724 as well. Okay, so that brings us to S total. So S total is simply E line times I line. And so we should be 240 times 9.151 amps. I'm gonna have to get tech to look at this. It's not working properly. Sorry for the mess, you guys. And it should come out to 2,196. And correct me if I'm wrong here, because clearly I have a couple of mistakes in my notes. VA. Anybody else get that? That's a correct number? Yeah? Okay. Okay.